Functions are ways to neatly encapsulate and reuse code. Let's define one and use it to compute via Fibonacci sequence and then discuss it a little bit. So you define a function using the def keyword, then you need to specify its name. We'll call it compute Fibonacci sequence, and we want to compute the Fibonacci sequence up until the nth element. The Fibonacci sequence is defined recursively, basically, by having so you have the initial two elements, 1 and 1, and then every next element is the sum of the other two. So the next one here would be 2, then the next element is 3, yeah, 3 and 1 plus 2, the next one is 5, the next one 8, the next one 13, and so on. Right, so we want to use this function to calculate a sequence such as this. So there's many ways of doing this, but one way would be to start by initializing a list. I want to return the sequence as a list. Okay, so we'll go sequence is equal to a list with the first two numbers, yeah, 1 and 2, 1 and 1. And then we can use a loop to compute all the rest. So I'll use a while loop here, while n is smaller than 0, bigger than 0, sorry. While n is greater than 0, we will append elements to this sequence. So sequence dot append, and now we'll append the sum of the last two elements in the sequence. Okay, we'll go sequence at -1, right, the last element of the sequence, plus sequence at -2, right? And we should not forget to decrement our loop variable n, right, so that n becomes smaller and smaller. And at the very end, when we're done with this, we should return the sequence. Okay, now let's see what this function does. So now we define the function, we define the behavior, right? So this calculates and updates a list, basically, right? And at the end, without the return. So from here to here, this code you should be able to read already. What we can do by putting this code into a function is call it if we want to calculate Fibonacci sequence first for 10 numbers and then for 11 numbers, and then from 20 we don't need to repeat this code over and over again. Rather, we'll just call this function with a different parameter. So this line right here, this is the function signature, right? It starts by indicating to Python that we are defining a function, specifying the name of the function, and then parameters. You're not bound to just one parameter. You can put a lot more in here, right? Let's say parameter. We don't need more parameters for this particular purpose, but we could add some, right? Parameter 2, and so on, right? They're limited by commas. What you can also do is add a default value for a parameter. Let's say the default value for this would be 10. Anyway, after this block of code got executed, this variable is what is called returned. Let me call this function and then you'll see what I mean by all this. So sequence is equal to compute Fibonacci sequence, and I'll call it with the default parameter at first, and then let's look what's inside the sequence variable. 1, 1, 1, 2. Yeah, I've made a mistake here for sure. Oh yeah, I'm subtracting the entire number. I should subtract -1, I'm sorry. Anyway, there we go. Now we have the first 10 Fibonacci numbers. Length of the sequence is 12 because we started by 2 numbers. So let's go while n is larger than 2. And now we have indeed just the 10 elements, so n elements of the sequence. So that's what happened. We didn't specify the number n right here, so Python just took the default value that we specified using the assignment operator here, yeah, the equal sign. This is not really an assignment operator, but yeah. It took the default value for the n parameter and then used it inside the function definition, right? We can also pass a parameter that we define. Let's say we want 100 Fibonacci numbers. Then the value of 8 will be 100. Let me print it so we have it more concise here. The value of n, which is then used inside the function, is 100 now, not 10. And as you can see, we have a list of 100 Fibonacci numbers. They become very large very fast, as you can see. And the sequence that we, this variable that we returned from here, right, we can access outside of the function afterwards. So this is called a function call using a parameter 100, and the variable that that results from the function call is called its return value, and this is a list containing n, in our case 100 Fibonacci numbers. Now I want to show you a mechanism called recursion. You can basically call a function in the function itself. So this time I want to calculate not the entire series, but rather the nth Fibonacci number. For that, I'll define a function, call it fib recursive, and it will take a parameter n, which is the number, the nth number of the Fibonacci sequence. And to calculate this, we need to define a stop condition, basically. So we'll put a condition in here if n is equal to 1. Let's do a single condition. If n is smaller or equal to 2, then but greater than 0, and n is greater than 0, then we return 1, right? This corresponds to these two first elements in the sequence. Let's go if n is equal to 0, then no, that's fine. Okay. So now we covered the first two elements of the sequence, and now we can use a neat gimmick. We'll say else we return fib recursive of n minus 1 plus fib recursive of n minus 2. And let's call this function on, let's say, the 10th Fibonacci number or the 4th. Fib recursive with the parameter 4. And I want to print this output. Fib number is equal to this. And now I want to print the fib number. And we have 3. 1, 2, 3. The fourth number in the sequence is indeed 3. Call it with 10, and I don't want to count all this, but you can see there you have the 10th Fibonacci number. I do want to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Yeah, correct behavior. So what you can see here is that we basically call the function again. This, when we let's follow the execution for a second. So we go in with a parameter called with 10. N is equal to 10. N is not smaller than 2 and not smaller than 2. So this condition evaluates to false, right? So we don't return 1. Instead, we jump in the else statement and then call Fibonacci with once with n equals to 9 and once with n equals to 8, right? And inside, on both sides, now we do the same evaluation. N on the one side, on the left here, yeah, is 9. 9 is not smaller than 2. Okay, so we jump in the else statement, and then we'll call Fibonacci with a parameter of 8 and with a parameter of 7, and so on and so forth. And we have a left branch of the execution and a right branch of the execution. At some point, n will be smaller than 2, and then we will return 1. And basically, we will have a sum of a lot of 1s here in the end, right? And depending on how deep we branch, so how large this number is, the sum will be different and will correspond to a different Fibonacci sequence. So this idea is called recursion, the one where we call the function inside itself, basically, with a different parameter. And here you need to be very careful with the stopping condition, right? Because if I remove that statement, this will result in an endless execution. Let's check this. Because it will go negative until it can't anymore, so forever. Or until this integer reaches the minimum allowed integer, so minus infinity. Or until the stack is too deep. So Python tries to avoid the situation by throwing you out of the function with an error. Okay, now I want to show you one last thing. Let's look at this function again. I'll just copy it from the top. Now, let's say I don't want to return the list of the Fibonacci number. Rather, I want to have it as a parameter list. I'll just call it L. And this will be empty by default. And now what I can do is remove the return value and instead append to this list. So I will have the sequence and I'll initialize it with n, right? And then I won't return anything. I'm just adding the Fibonacci numbers to this sequence L. And now I'm calling it with the second parameter L, and I'm putting the initial values of Fibonacci here. And let's see what happens now. There's nothing in sequence because the function doesn't give you any value back, so that is indicated by none. But if we look inside the list that we passed as a parameter, we'll see that we actually will have the entire Fibonacci series right there. I need to convert it from a range object to a list object. There we go. I think I made a mistake here. My bad. I did a mistake. So let me modify the code and fix it. So I want a Fibonacci sequence to be stored in this list. I'll start it with the first two elements, 1 and 1. And now I'm passing that list as a parameter. Fib sequence. Right? So as I told you before, we don't have what? Let me overwrite this. We printed L, which was the old variable, not the new one where actually the fib sequence is in. Sequence, right? Because we executed this cell, so we had the old variable L still stored in here. And now, voila, we have what we expect, namely the first 100 elements of the Fibonacci sequence. Okay, so what happened here? Basically, we passed a list which is mutable, and this is the important note here. We passed the mutable object to a function. The function did something to that object itself, right? It appended diverse numbers to the list, diverse Fibonacci numbers, and then we didn't return anything. So the return value is none here, but the list that got passed as a parameter, since we defined it above here, right, got modified. And now, after the function call, we see the modifications that were done to it. This is called call by reference, basically. We passed, instead of passing a copy of this list here, we passed the reference of the list itself. On the other hand, n, if we modified it, and we did, still nothing happened to it. If we pass, let's do that for n. So yeah, sorry, n is equal to 10, and then instead of passing 100 there, I'll pass the variable n. And now let's look what happens to the value of n after the functional call, and you'll see that nothing happens to it. N is 10 as it was here. You see, so for basic data types, for immutable data types, when we pass that data type to a function, a copy of it is created, and we work within the function, we work on that copy of n, right? Let's say 100, not 10, so that you know the difference between the default parameter and one we pass in here. And still 100 isn't modified. So immutable data types don't get modified within the function, whereas mutable data types like the list do, right? If you pass a list before the function and modify it within the function, you'll see the modifications afterwards. If you pass an immutable argument to the function, that argument will be copied, and the function will work on a copy of it. So n stays the same after the function call.